So as I was saying, we were working on solving polynomial equations by factoring. We're going to learn some other methods next class, but today we're going to be working on that factoring. So a lot of our polynomials you'll be able to factor, which is why we reviewed it. So you got your GCF, you got your dots factoring, you got your trinomials, your grouping, all that good stuff. So always look for our GCF first. So starting with number 1, do we have a GCF there? Yes, we do. Our GCF would be an x. Both of those terms have an x in them, so we pull the x out. So we're left with the x squared plus 1. Can we factor x squared plus 1 any further? No. If it was a minus sign, we could, but being a plus sign, we can't. So we're going to set these equal to 0. So the x side, that one's really easy. X equals 0. We got one of our roots already. Other side's going to have a little bit of work to it. We have x squared plus 1. So we're going to subtract our 1 over. So that gives us x squared equals negative 1. And then to undo our squared, we do our square root. So remember, when we do a square root of both sides, we have really two answers. One's positive, one's negative. And then the square root of negative 1 brings back our imaginary letter I. So the square root of negative 1 is simply just going to be I. So x equals 0, and then x equals plus or minus I is going to be our answers for those ones. So some of these answers are going to have I in them. Some of them are not going to have I in them. So like, for example, this next one won't end up having I in there. But first thing we do need to do is get it equal to 0. You always need to have your polynomial equations equal to a 0. So subtract that 3x squared over. So that negative 7x squared minus 3x squared becomes negative 10x squared. So again, now we can factor. Equal 0. We're going to try our factoring. Is there a GCF? Yes. 2 can go into both 4 and 10. And then our lowest exponent on the x would be squared. So 2x squared is going to be our GCF there. Divide that original polynomial by your 2x squared. We get left with 2x minus 5. So again, both of these get set equal to 0. So 2x squared equals 0, 2x minus 5 equals 0. So for the 2x squared, we would divide by 2 here. But 0 divided by anything is 0. And then again, to undo squared, you have to square root it. That just ends up being x equals 0. Now, going back to some notes that we did, not last week, but the week before, it's been a little while. Because this x was squared, what would be our multiplicity for 0 if we were to graph it? Does anybody remember what our multiplicity would be here? It would be that 2. This would be a multiplicity of 2. So this would bounce on the graph at your x-axis. So when you got to the x equals 0, instead of going through the x-axis, remember it would bounce and then come right back up or down depending on the direction it was coming in. That one would have a multiplicity of 2. Going back to the other side, add my 5 over. So I get 2x equals 5, divide by 2. X equals what? 2.5. So here's our answers. X equals 0, and then x equals 2.5. So really, this is all about remembering how to do your factoring. All right, let's take a look at example 3. X to the 4th minus 64. Do we have a GCF there? Nope, no GCF there. So we have two terms. It is subtraction. This exponent is even, so that means that is a perfect square. 64, is that a perfect square? Yep. So this is going to be our dots factoring. So two sets of parentheses equal to 0. X to the 4th would break apart into x squared and x squared. One's positive, one's negative. And then the square root of 64 is 8, so plus 8 and minus 8. So then again, if I look at my x squared minus 8 over here, it kind of looks like it's going to be a dots factoring again. The only reason it's not is because your 8's not a perfect square, so we can't factor that any further. So we go to the step of setting these both equal to 0. So I'm going to go to this side over here where it has the x squared minus 8 just because I think it's going to be a little easier initially. So I add my 8 over first. So I have x squared equals 8. How do we undo our x squared? Yeah, square root sign. 8 is not a perfect square, so we have to do that step where we find what is the perfect square that goes into 8. 4 and 2. So then the square root of 4 becomes a 2, so we have plus or minus 2 radical 2. So remember, that gives us two answers. We have positive 2 radical 2, and then we have negative 2 radical 2. The other side is going to be very similar. There's just going to be one difference there. So again, first thing I do is move my 8 over, so this time we would have to subtract it over. Square root both sides. So even though it's negative 8, remember, we can still separate it into negative 4 and 2. It's just the square root of negative 4 makes it 2i. Whenever we have that negative under a radical, that turns it into I. So there's our other two answers. Since it was x to the 4th, I knew we had to have 4 answers. So we have positive 2i radical 2, negative 2i radical 2, and then positive 2 radical 2, negative 2 radical 2. Those are our 4 answers. All right, let's try another one. Number 4. Do we have a GCF? Yep. What number goes into 5 and 80? 5. And then both terms have at least one x, so 5x. So then that leaves us with x to the 4th minus 16 when I divide by my 5x. So then x to the 4th minus 16, it's kind of like our last one over here, number 3. It's a dots factor. Those are both perfect squares. So it'll start with x squared and x squared. Signs will be different. One's plus, one's minus. And then what's the square root of 16? 4. 4 and 4. Now one of those can get factored one more time. The one with the minus. So x squared minus 4 would factor into x minus 2. And then x plus 2. And then those other ones are going to stay like they are. They can't be factored again. So I bring down my 5x. I bring down my x squared plus 4. set all 4 of those equal to 0. So my 5x equals 0, my x squared plus 4 equals 0, x minus 2 equals 0, x plus 2 equals 0. So over here, divide by 5, and we get our first answer, x equals 0. And then I like to skip around, do the easier ones first. So this x minus 2 here, we would add 2. So x equals positive 2 there. For the x plus 2, we would get x equals negative 2. Those ones just change the sign. So then that other one I didn't do yet. Subtract our 4. Because I have x squared equals a negative number, I'm going to have an I in there. Take the square root. X equals plus or minus 2I. So 0, 2, negative 2, plus or minus 2I. Those are our answers. All right. Let's take a look at our fifth one there. Our fifth one is a perfect cube. It's kind of factoring that we need to keep working on. So our perfect cube, when we're adding, which is what we're doing here, factors into a plus b, a squared minus ab plus b squared. So remember, a and b are the cube roots of what we started with. So what is the cube root of x to the third? That would give us an x. So anywhere we see an a, we're going to put an x. Cube root of 125. Use your calculators if you need to. Under that math button, gives you the cube root. 5. So anywhere we see a b, we're going to put a 5. So again, it starts off adding the two of them together. So x plus 5. In the other parenthesis, a squared, so I'm going to take my first one and square it, so that becomes x squared, minus the two of them multiplied, so x times 5 would be 5x, and then plus the second one squared, so 5 squared gives me 25, and then equals 0. Now, that trinomial over there, that is not factorable again. So let's deal with the x plus 5 first. That one's the easier one. We get negative 5 as our answer there. For the other side, as I said, not factorable, so we have two choices. We can do completing the square, or we can use our quadratic formula. So which one do we want to go with? Okay, we'll go with completing the square. So for completing the square, I need to move my 25 over. And then I add in some spaces there, a space on each side. So then for the number on the space, you're going to have to use your calculator because we are going to get a little bit of a decimal here. You got to take 5, divide it by 2, and then square that. So 5 divided by 2, and then squared. What does that give us? 6.25. So that left side always factors into x, in this case minus because that was negative. And then half of 5, it's always half of that term when you're factoring squared. So negative 25 plus 6.25 gives us negative 18.75. All right. So now it's like what we were doing with our x squares. Now we square root it. All it does is it gets rid of that squared on the outside of the parentheses. Now don't put the negative in there. Let's just see. Is 18.75 a perfect square? No. Could give us a decimal. Okay. So then let's turn 18.75 into a fraction. So type in 18.75 and do math, enter, enter. Let's get a fraction. So I do that because 4 is what? Perfect square. Is there a perfect square that goes into 75? Yep. So it makes it a little easier for us to reduce it. So what is our perfect square that goes into 75? 25. So that's going to become negative 25 and 3. Because there's a negative under the radical, what does that turn into? I, so that becomes a 5i radical 3. And then on the bottom, the square root of 4 is going to become a 2. And then we just have to add our 2.5 over. 2.5 plus or minus 5i radical 3 all over 2. And that one was a lot. All right, so what I want you to do, go down here. Try 9 and 10. Those ones are not cubes. Those ones are the other kind of factoring. So I want you to take a few minutes, try 9 and 10 on your own, and then we'll go over them. So this GCF of 10, can I really set that equal to 0? No, 10 doesn't equal 0. That's just silly. So those other ones we can set equal to 0. So we'll do that. Subtract our 1 on that x squared plus 1. Square root both sides so we get plus or minus I. So square root of negative 1 is just I. And then we end up with a positive 1. And a negative 1. So again, what we're doing on these is we are solving for the roots, also known as your zeros. So if I were to graph this function, I would know that I have a root over here at negative 1. I have another root over here at positive 1. Would I be able to graph, though, my two imaginary roots? No, because I don't know where those are going to end up being. So actually what it ends up looking like on the graph, if I type this in, is 10x to the 4th minus 10. Put that in there. The only two roots that we can see are the 1 and then the negative 1. If I go to zoom fit, again, it still just shows us the 1 and the negative 1. That doesn't actually zoom fit it very well. still doesn't zoom fit it very well. But anyways, what ends up happening is your imaginary roots are off somewhere else. So like for this one, so this is going to go up. It probably like bounces around down there, so it gives you a couple imaginary roots somewhere in the middle of nowhere. That's what happens with those i's. So the only two roots you would actually be able to graph are the 1 and the -1. The other ones you wouldn't be able to. All right, let's take a look at that next page. Let's have you try to do a few more here. Let's have you do 11 and 13. So take a few minutes, try 11 and 13. Thirteen has one that's a little bit trickier with your factoring because you've got that 3 in front of that x to the 4th there. So that would break apart into 3x squared and then 1x squared, because if you multiply those back together again, that's your 3x to the 4th. And then multiplying for 16, we have a few options. I went with the 8 and 2. So then if I check myself by multiplying these two terms together, I'd get a -8x squared. And then if I multiply these two outside terms together, I'd get a +6x squared. So when we add those together, there's that middle term of -2x squared, so we know that we've done it correctly. So just like all the other ones, we're going to set these both equal to 0. So I add my 8, divide by 3, take the square root, and then let's see who remembers. Can I leave radical 3 in my denominator? No, can't have radical 3 in our denominator. How do we get it out of the denominator? Got to multiply. Multiply the top and the bottom by that radical 3. So that gives us plus minus the square root of 24, because 8 times 3 gives me 24, over 3, because radical 3 times radical 3, just cancel each other out, make it a 3. So what's our perfect square that goes into 24? Everybody always wants to tell me 12 and 2. 4 and 6. So the square root of 4 is 2. So we get x equals plus or minus 2 radical 6 all over 3. So there's 2 of our answers. Other ones subtract are 2. Take the square root of both sides. The negative just comes out as an I. 2 can't be simplified any further, so the 2 stays under the radical sign. So plus or minus I radical 2. So then taking a look at 15, we got 4 terms there. Again, still always look first, is there a GCF? Not between all 4 of them. So this is why we group them. So we group those first 2 together, we group the last 2 together. Now looking at just those first 2 terms, is there a GCF? Yes, x squared. So then we get x plus 2. Look in those last 2, is there a GCF? 5. And then we're left with, again, x plus 2. Those are the same, which means we are doing it correctly. So I'm going to pull that out in front. Their GCFs get written together in the other set of parentheses. So now we set them both equal to 0. So that first one I get x equals -2. That one's a little easier. Second one I have to subtract my 5. Square root it. So we get plus or minus. That negative comes out as an I. 5 stays under that square root sign. Plus or minus I radical 5. So I'm taking a look at our last one there again. We've got 4 terms. Because of this 3, there is not a GCF like we would have initially thought. So I'm going to group my first 2, group my last 2. What is our GCF within the first 2? X squared again. So then we're left with 2x minus 3. GCF within the last 2. It's going to be a -16. Negative because that first term in the last 2 is negative, so you want to keep that negative sign pulled out. So then we would get 2x minus 3. So that 2x minus 3 goes first. Well, it doesn't have to. You can put it second. Some people prefer to do that. But then x squared minus 16, that one can factor again. That would become x minus 4, and then x plus 4. And then I'll just bring down my 2x minus 3. And I set them all equal to 0. So I get a 4, a -4, and a 3/2 or 1.5 if you choose to write it as the decimal. So again, we factor them to solve them to find their roots so that we can try graphing them eventually.